All right, last time we started talking about building our own custom classes in C#. And I first want to make sure that you've got a pretty good handle on why we're doing this, all right, and our end goal, where are we going. The user's perspective of the programs that we're going to be writing, like your assignment tracker, except for the stuff that some of you have already been adding to open files and save files, the way the program works is the same. When we do your gas mileage program in Unit 2, adding some validation to it, the user's perspective, the user's view of that, the GUI over here, is really pretty much the same. What we're trying to do in this unit and from now on is to divide a complex project. What we want to do behind the scenes is make sure that as our projects get more and more complex, that we get divided into logical groups. So our database and the access to that database is going to be stored in a separate class. That's Unit 3. In this unit, we're going to learn some very basic skills for designing a business class. And that's where all of the logic for our program goes. All rules go in there. The rules part of it, we're going to save for Unit 2. In this unit, Unit 1, we're going to learn how to build one of these things, how to create it, how to do the pieces parts, and leave a lot of the complexity out. And then once we've got these two pieces split out, the GUI is just a simple matter of throwing things on the form and do they look right, and as you'll see in Unit 2, writing validation events that transfer control to the business class. So every time we leave a field, let's make sure that's right. Go to the business class, say, here, take this. Does it look good to you? If it does, cool. Otherwise, it sends back a message saying that's not right. Let's fix it. It's ultimately where we're going. We're going to split this up because as projects get huge, we need to be able to get our head around separate parts of these things. Remember back to last semester, we were doing prototypes very early on. In the design phase, we did a prototype, said lay out the screen. Doesn't do anything, but lay it out. We can still, now what we can do is put most of the logic over here. Not all of it. There's still some code that needs to be written in the GUI. But most of it, taking a prototype and turning it into a finished GUI is pretty simple. Because most of the complexity is now going to be stored here in the business class. So ultimately, that's our goal. What the user sees is not anything different. I could show you the finished assignment tracker and it would look pretty much like the last one. I could show you the finished gas mileage program and it'll look a lot like the last one. However, behind the scenes, from a programmer's perspective, all of the business logic, what makes for a valid mileage, what makes for a valid MPG, what makes for a valid vehicle, all of that stuff will be stored in here. And all of the analysis to say what the user just typed will be done in here. There is communication. Notice there's a little double-headed arrow here. There's communications both ways here to take care of that. So what we're trying to do is isolate our GUI from the business logic. What isolation also allows us to do in many cases when we create these classes is create reusable classes. So if we decide to write another program that has something similar to this, we can reuse that. So it kind of ties into the reusability component of systems analysis. It's another reason to split stuff out like this. So that's our big picture. That's where we're going. Last time we started talking about some basic class concepts like instantiation and what a class is. A class is like a template. It's a container. It's a black box. Those are all kinds of analogies that you've heard before, right, that maybe you can get your head around. But it's a tool that's used by another program or programmer. Another program uses this. Humans, the users that you think of, the people who are going to use your program, do not have direct access to these things. They don't even know they exist. All they know is the program does its job. The fact that behind the scenes it's split into a 3-tier model, nobody recognizes. Most of the websites, if I go to my attendance website, this is built around a 3-tier model, but when I use it, there's nothing here that tells me that that's what's built around. You don't get to see that. Human users don't get to see that. When we talk about users for a class, however, we're talking about another program or a programmer. I need that class and all of its functionality for my new program. So the user of a class is another program. What we're trying to put in here is the business logic, but really what we're doing is we're encapsulating, putting all into one container. We're encapsulating the data that's related to this object. In your assignment tracker, it's one assignment. That's an object. What data do we need to store about an object? That goes in the class. What kind of things can we do to an assignment, with an assignment? That goes into the class. All of that's encapsulated. So all the variables, if you wish, I hate to call them that because that's not the technical term. All the variables that we need for assignments go in there. And all of the methods, all of the functions, all of the functionality related to assignments go inside this custom class. It's all nice and neat packaged. We can pick it up, send it someplace else, and use it in a different program. Favorite example is a text box. Text box needs to know how big it is, needs to know what text it has inside it, might have font size, all that stuff. But it also has behaviors, methods. When I type in it, text appears. When I highlight it, it turns blue. Hit the backspace key, it goes away. If I right click, a menu shows up. All of that had to be coded someplace. And all of that gets encapsulated into a text box. When you ask for a text box, you drag a text box and you get everything. You get sizes, you get fonts, you get text, and you get all those behaviors that all comes with every single copy of the text box.
Just wondering, so we'll be writing our custom classes, so it's pretty much the same as like us creating our own kind of text box with our own methods. Right?
A lot of these classes, the only difference, yes, they're kind of similar to text boxes. However, all of the classes that we are going to build do not have a visual component to them.
Oh.
Okay? It's a conceptual assignment.
Is it possible to?
Yes, it is possible to create what are called custom controls. When you do the add new item here, when you do the add new item, it is possible, please, there we go, to create a user control. That's a custom control. Now that's a visual thing. We're not going to cover that in this class, in this IT software developer program. You want to learn how to do that, go find a couple of YouTube videos and you can learn how to do it, but it's not something that I need, that I have time for here. It's not that it's not useful. Right. Wouldn't it be nice to be able to create a text box that when you double click it automatically does something? You could. What user controls allow you to do is basically take existing controls and merge them, give them new powers that they didn't have before. It's called inheritance. It's another term that goes along with object-oriented programming. Inheritance is using one control and all of its powers, all of its capabilities to create a new one and giving it new capabilities. We still now have two separate ones. We have the basic text box and then our super text box, or whatever you want to call it. Okay. Yes, you can. I mean, the answer.
I was just wondering if it was possible to like edit an already existing control and like modify it
to do something it doesn't know how to do.
Yeah.
Not without creating a user control. You do not have access, because it's kind of locked down. You don't have access to a text box. You don't have access to its class. What most people do is once a class has been tested thoroughly and it seems to be complete, is they will turn it into a binary version of that class, a ones and zeros version. And when you want to use it, you can attach that to your program and use it. But you have no access to its source code anymore, so you can't add your own features to it. So many companies will do that. Yes, we have this class, but it's stored in, often it's stored in a DLL file for those of you who like that Windows stuff. It's a dynamic link library. It's a library of pre-compiled classes. The text box comes from the .NET framework that's pre-compiled, that gets sucked into all this stuff. So if you create your own, and we're not doing it here, but if you create your own in the real world, often they get turned into binary versions that nobody can change. You have to have the original if you ever want to enhance it and change its behavior. Good questions. All right, so inside of a class, to create a class, we did that add new thing. All right, we did it last time. Add new item, or you can go right to add class. When you add a class, this is already selected, you give it a name. I like to put the prefix CLS on it because then when I have a whole bunch of classes in my Solution Explorer, they're all together because they all have the same prefix, so they alphabetize in the same place as a group. So I like to put a CLS prefix on my class file name that it's stored in. But the class itself, I take it back out. So we did that. We created this, and what that did is gave us our class pizza order last time. And this, by the way, for anybody that was missing, is on OneDrive. Make sure you get the 1 o'clock version, though they should be very similar. All right. So here's that file that we created last time. It's called clspizzaorder.cs. It's a CS, it's a C# file. And then the first thing we did is took the CLS off the class name. By default, Microsoft Visual Studio made the class name the same as the file name. When we use the class, we don't want to have to put a CLS in front of it every single time, just like there's no CLS text box. We just say, I need a text box, give me the text box. There's no CLS stream reader. Somewhere there's a file that stores all the details about a stream reader. What that file name is, we don't really care anymore. Now, when you and I create our custom classes, we're going to have both. This is the file that contains all the text, all of this text. But the name of the class itself does not include a prefix. Class names, Microsoft has set the standard here. They always name their classes using title case. When you ask for a stream reader, it's capital S, capital R. Text box, capital T, capital B. So we're going to follow that standard just to be consistent so that we can recognize this as a class. So that's how we created it, went to File New or went to New Class, gave it a name, stripped off the CLS right away. Remember when we built forms, there were these 6, 7 steps you should always do. There's a couple of steps with files. Create it and immediately strip off from the file, not from the file name, from the class name, the prefix. Inside of a class, you'll typically find 4 different things encapsulated. Remember, this is an all-inclusive container. It's got everything in there. It has members. Some people call them attributes. The book calls them backing fields. So again, why all these different names? It depends on where you work, but the more common term, the more generic term is members. These are the class members. The members are basically variables that store the data. As an example for a text box, the members might be the size of the text box, its height and its width. It might be the border style of the text box. It might be the text that's stored inside it. All of those have to have some place to store that information. How big is this text box? This many pixels. How tall is it? This many pixels. You gotta store that someplace. Those are members. I also mentioned last time that if we're implementing a database, like we did in RDD today, we're getting started doing an RDD, typically every table has its own class, and the members, at the very least, are the fields in that class. So they correlate very, very closely. We haven't gotten this far yet, but then our class will also contain properties. Remember that the members are invisible. They're hidden. The user, meaning the other programmer, does not have direct access to those members. They have access through the properties. The properties provide the capability to give the current value of the size of a text box to the user. When I ask out here comes my form, please. I am right now asking Visual Studio to give me the information about this text box. All of this property list just changed. For every one of these properties, there is probably a member that goes along with it. And so I'm asking, what's its current size? what's its height and width, what's its current tab index. All of these properties provide me that information. I don't get to mess with the members directly. They're members that keep track of this stuff. What's the current text in that text box? Nothing. But there's a variable, a string, that's empty. If I put Voker in here, now behind the scenes, I've told the property, please put Voker into that member. I don't even know what member it is, but please remember this for me, is what I'm kind of saying. The properties are what other people use to change and get, it's called setting and getting, to get and set the values of the data members. We don't even know what they are. We don't care if we're the users. All we care about is what properties do I have, right? When you're writing code, you press dot and say, what properties do I have? How are those implemented behind the scenes? Is the size, is that 2 numbers? Is it 1 number? Is it another class? Are they doubles? Are they integers? We generally don't care. They're there. I want to change them, I change them. So what the properties allow us to do is get at these private members. We already wrote some members here. We made them private. Okay. Notice the private here. That means nobody but the class has direct access to these things. So this form that I have, form pizza, does not have access to. You can't change those. Not directly. If we want to change them, we have to ask permission. We have to go through the gatekeepers, the properties. The main reason is what we will be doing when we do validation, when we have our business rules, that's where they go, in the properties. The properties, we will write code that says, okay, you got a new value. Let's take a look at that new value. Does it meet the business rules? Does it fall within the acceptable range? If it does, great. Put it in the data member, but it doesn't go there directly. It has to go through the property inspects it, and then saves it. The reverse is also true. If our main program needs the value, it asks the property. And the property grabs that and sends it out. We don't usually do much with it when we're sending it back out, but when we're getting a new one, the properties validate. That's where it happens. Miguel?
Oh, I totally forgot what I was going to ask.
Good. Another one of my strategies would have you wait a little bit, see if you can forget. Okay. So we haven't written any properties yet. We will. These members that we created last time are private. My form cannot access those directly. We have to create, and we will, properties that give us access to that data. Both read and write, get and set. We also need to define constructors. Whenever the user instantiates, what's instantiate mean? Use this template to create a variable. Right now, what we're defining is a template. We're creating our own cookie cutter. We're creating our own cookie cutter. Later on, the form, the user of this class will instantiate it, meaning make me one of those. Give me some memory, enough to store all that stuff. Make me one. When we instantiate, we use constructors to define how to initialize it. If I instantiate a new pizza shop order, what should go into the date? What should go into the customer name? A brand new one, what should go in there? Initially, the date might be the current date. The customer first name, last name, and size, first name, last name, definitely blank to start with. That's what we have to define. Maybe we have a default size and most people come in and order larges, so we start with large. We can do that. You saw briefly in RDD today. Again, I'm trying to tie all this stuff together. In RDD, part of our database design was, is there a default value for this field? If there is, we put it in. That's a business rule. Here's the default value for that. Here's the rule. Put it in there. That goes into the constructor. So that every time I create a new order, the large is automatically picked. How'd you do that last semester? You put it into form load, right? When the user, or you put it into button clear. When the user clears the form, pick the large button. But that's a business rule. It doesn't belong in button clear. It belongs in the business class. And the business class constructor is where some of that gets done. So this is for initialization. And then finally, custom methods. What can I do? Classic example, here's my pizza order. I want to calculate the total. How much am I going to charge them? There's rules for how that gets calculated. It's all in the business class. This is a custom method to figure that out. Because a method is a piece of code. It's not a value. Properties and, members are values. They just store stuff, strings, doubles, decimals. Methods do things with those values. The methods, the custom methods will actually be inside the class. So before the beginning and end of the class, they'll be inside there. And because they're inside the class, they have direct access to these members. So they can actually use them and don't have to ask permission if we don't want them to. So that's the big picture. We know how to build a class. We just do add new when we get this empty class. Hard part's figure out what are you going to call it. But what's the name of the object that you're describing? What's the name of the table in your database? Maybe it's a customer. Maybe it's an order. Maybe it's a student. Usually whatever the name of the table is. Now I said last hour the tables are plural. Take the S off. Now we're creating an object that describes one student, one class. My pizza order. How do we know what the classes are? You ask the owner. Comes from the field list. It comes from the table descriptions. If I'm tying this to RDD, I know the field list for this table for my pizza order because it's in the table. These are the fields that are in the table. It's almost. Right? As a starting point, it is a one-to-one correlation. For every field that you have in the database, you have a mirroring, if you will, field in the object. It's not a strong rule, but it's a pretty good starting point. So last time, we started defining members. Members are just like variables. When I define everything you do to the class goes between the beginning and the end class curly bracket. Everything. There should be no code out here. There should be no code above. Everything comes between the class and the end class. So why do we have the rest of that junk? This stuff simply defines which namespace this belongs to so that our class can communicate with our form. If they're not in the same namespace, they can't see each other. So we need that. That's a C# thing. Not everybody, not all the languages do that. Then up here are the using statements that allow us to bring in predefined code. Now I did find it. Now I wonder if I can find it again. If you right click up here, is that where I found it? Organize usings. Yep. If you right click and organize usings, you can remove the ones you're not using. Remove the usings you're not using. It sounds a little goofy, but remove the pre-compiled pieces of code that we're not using. Why are they in there if we're not using them? Like link and what do they take out? Whoa. Took them all out. It's Microsoft trying to think, well, geez, every time we write code, we always need these, so they put them in there. I guess we're not professional enough yet to need all that stuff. This should make my program smaller, probably will make it faster because I'm not bringing in code that I don't need. So that's a quick way to do that. Next year when I teach programming logic beginning, that's going to be a right click and before you submit, remove everything you're not using.
Otherwise you get half a point off.
Otherwise you get a half point on it. So that's something you can add to your list of things to do as well. So that's what all this other stuff is. This is the meat of the class. Everything between the class statement and the end class curly bracket. That's where everything goes. Everything. I normally put my data members, backing variables, whatever you want to call them. Okay, I'm going to use the term members. I usually put them first so I can see them. They're the foundation of this class, so I put them first. There's no rule that says they have to be first. They can be last. In my notes, I list these pieces of a class: members, properties, constructors, and custom methods. I usually create them in that order. But you can mix and match and turn them around inside out, and when maintenance time comes, you're going to hate yourself. At least keep them together. The order doesn't matter. data members, as I've said before, are basically variables. They're of type string, they're of type double. What's a little different about them is they are always designated private. That is a design decision. When we use a three-tier model, the data members inside of a class are private. There are exceptions to that rule. We'll have some public data, actually they're more like constants, we'll make them public. Because if they're constants, nobody can change them. Why not let the whole world see them? Here's the rules. Right, we'll see that later. For right now, all of the members, and those, by the way, are not members. Those are constants. It's a little different. All of the members are private. The only piece of code that has access to them is anybody inside this class. Everybody outside of the class can't even, they don't know they even exist. The other thing that's different is we start the name with an underscore. Later on, we're going to define properties for hours, for this example, hours worked. We define the property, it'll probably be called hours worked. To keep straight which one's the property, which one is the data member, a very common technique, and we'll follow it, is to put an underscore at the beginning of your data member name. It's not a rule. C# could care less. It's again a maintenance thing, so the next person who looks at this class says, okay, those are data members with the underscore versus properties. There are other ways to do it. We also have a standard that says every variable has to be described. These are basically variables. They're just stored inside of a class, so you must describe every one of your data members. What do they store? It's just my standard. Doesn't mean that when you get to Skyward or Sentry, they're going to have the same standards. They may not care. I have good member names in this case. I should be able to figure out what cust first name means. Probably can figure that out, but a good description ensures the next person knows what's stored in here. So we built a bunch. We got a few more to go yet. Okay. Notice that for every one of my fields, think of this as a field list for a table. For every one of my fields, there's a name, but these aren't camel case. I go back to camel case. And I can use this field name, or I can expand it, or I can shrink it, or I can do whatever I want. But typically, the field names in the database make pretty good field member names. Why change it? You're just confusing people when you do that. So here it's called order date. Here it's called order date with one exception. That's the underscore. Changing gears to RDD, my apologies to the couple of you that aren't in that class, but in relational database development, we talked about step 9 is define the field types for these. 9 out of 10. It's the last step. What data type? This is a date. This is a string. How big is it going to be? This is a string. These are Boolean. This is an integer. All that's already been defined, probably been defined. And so we shouldn't have to guess too hard about what types they're going to be. In this case, the definitions are not available to me, so I have to make some assumptions here or define them. The date's obviously a date. Names are strings. The size is also a string. And now we get into this pepperoni, sausage, mushrooms, onions, green peppers. Those either are on the pie or they're not. So they're Boolean types. So I'm going to create some more variables here. In the interest of time, I'm not going to describe them. I will hopefully go back before I save this as a final for you to copy from, or I should say use as an example. I will put comments on all of these members so that you remember to do that. They're all private. These are Boolean. And the first one I want to worry about on that list there is pepperoni. And I'll put one comment here so you can see. Did the user request pepperoni? And now I just keep going. So you can keep going as well if you're following along. Don't forget the underscores. All I'm doing is making them camel case. Somebody asked me previously, well, couldn't I put a comment up here that says, did the user request the following toppings? In the real world, yes. My standard, no. Every member, every variable gets its own description. Yes, that's painful right now, but that's our standard. And I will update these before I post it permanently. If I forget, you still have to remember. Now the last four here are not really a whole lot more complicated. Number of pies, in other words, how many types of this, and once again, just like last semester, number of pies here is how many of this exact type of pizza did they order. And I believe the soda, no, I don't think soda comes into it here. Last semester we had some soda going in, and if you ordered 3 pies, you got 3 sodas to go with it. Here you only get 1 soda, I think. I'll have to check. So this one, number of pies, is an integer. And there it says num pies, so I'll just do the same thing here. Now in this case, because I'm abbreviating num pies, it's a good place for a description. What if the user wants 1 sausage and 1 pepperoni pizza? Wrong pizza shop. Go next door where they have a more elaborate software system that can handle that, because we can't. Actually, in this one we can. It's just 2 different orders. In the real world, yes, we'll deal with that. But it just gets really complicated really fast, and that's not what the point here is how do we create our own class. Do they want a soda, yes or no? Boy, that one I don't remember. Well, I can look at the design. The design is a combo box, so there must be a list of flavors here that I'm going to pick from. So that's got to be a string. Cheese sticks. It's an integer. How many cheese sticks do you want? I think I finally decided that cheese sticks is 2 words, so I'm capitalizing the sticks. For a while there, I wasn't sure. Every time I type it as 1 word in Word, I get dinged, so must be 2 words. And finally, coupon. That's a decimal because this is a value of the coupon that they've given us, and that's money. There might not be one, right? A lot of people come in without coupons. If they don't have one, doesn't mean we can't take their order. This is going to be an optional field. So are cheese sticks optional? If you're doing somebody else's design, you just create one of these members for every single field. It's in their design. If you're doing your own, my advice, design the database first, and then take 1 table at a time and build a class for it. Each field that's in that table, make a member for it. Now, I don't want you to follow here, but I want to demonstrate something. I'm going to go to the actual form code for form load here. I'm just going to demonstrate do not follow because we're not even, if we use this, it probably won't happen here. But let's say that I want to create a pizza order. What's not the create? That's the wrong word. What do I want to do? Instantiate. Instantiate. That's hard to say. If I want to instantiate a pizza order, I first have to designate, I'm creating a variable that's going to point to a brand new pizza order. I first have to designate its type, is the way we've always thought of it, or its class. This thing that I'm creating is a new pizza order. Then this is just like a variable, I have to give it a name. that doesn't create a pizza order. Okay. What that does is it creates a pointer that can point to a pizza order. And that's it. It can't point to a stream reader, or it can't point to a file, it can't point to anything but a pizza order. It's a very specific pointer. It can only point to a pizza order. If you actually want to instantiate one, you have to say new pizza order. And you put parentheses there. Now again, don't copy that. Just looking ahead. This is coming in the notes. Right? Just looking ahead. How am I going to use this thing? Now, this pizza order, poof, we've created a new one. We've done what? We took the cookie cutter and went stamp, and we made the pointer point to that one. So we took our definition of a pizza order, which right now is just a bunch of members, and we created one of those. That's how you instantiate. You define a pointer to that object, and then you make a new one using new. New says instantiate. What this also did, behind the scenes, is invoke the constructor. Wait a minute. We didn't do a constructor. Every class has a default constructor. Even if we don't write it, there's one there. What does it do? It takes every one of those objects or every one of those members and creates enough memory for all that stuff that we ask for. And what does it put in here? Nothing. What does it put in here? Empty string, actually nulls. Just like the variables we did before, if you declare them and don't put anything in there, what do you get? Pretty much garbage. Now, here's the point. A little bit later, I should be able to say an order, please, dot. But notice what's available to me? Where's my pepperoni? Where's my order date? Where's my sausage? Where's my cheese sticks? They're invisible. They're private. I'm in the form. And I'm trying to look inside the black box right now, and you're not allowed. You're not allowed. Okay. Now I'm going to leave mine there again for demonstration purposes. Okay. I'm going to leave that there because I'm going to come back in a minute and show that all of a sudden things start popping up on that list. But what never pops up on the list are my data members. Never. They're invisible to everything except the class itself. Except the class. Questions about data members? Make you read my notes and write questions and email them to me. No.
Spell checker again?
The spell check? I don't remember. You'll have to look it up. Go to Programming Logic Beginning. There's a recording. This is an email I sent to you. I forget. It's a tool that you add in here. It's under add-ins, but I forget how to do it. Oh. Okay. Now, as I mentioned before, and as we just demonstrated, these are invisible to the outside world. They're inside our little class, inside our encapsulation, inside of our object. Nobody else can see them. But in order to use the class, we want to be able to get to those. We want to save a new order date for this pizza. We want to save the fact that there's mushrooms and onions on this pizza. So how does the outside world get to this inside stuff, as we said before, through the gatekeepers, through the properties? So now we have to define properties. And pretty much for every data member, there's a property, a corresponding property. Not all languages include properties. What they do instead is you have a method that does exactly the same thing. Most languages today include properties. They may not call them that, but they include them. C# does, so we're going to take advantage of them. Properties allow the user program, remember the user is not a human user, your cousin. The user is you, the other programmer who wants to use this class. Allows you to get at these, not directly, but allows you to get at them. The real value of properties come when we try to change the properties. We can validate the data before we put it in there. And I'll demonstrate that. We'll do most of that demonstration next unit. This is not the validation unit. This is the get your head around classes unit. Next unit, we're going to plug in the validation. But that's the real power of the properties. I normally put the properties below, not required. Usually every member has corresponding properties. It's not a rule. Occasionally you have properties that don't have members, which is weird. So here's what a property looks like. First of all, public. What does that mean? The outside world can see it, a whole. So this property is public. It has the same type as the data member. So if my data member is a date time, my property will be a date time. And then it has a name. And to keep my sanity, the name of my property is the same as my member without the underscore and its title case. So let's build one. Start building one, and then we'll keep going on that description. I need a property, so first I'm going to put a little description here. Let's see, is this a good time for this? I think so, but I remember how to do it. There's something in C# called regions.
That's what Paul showed me.
Paul showed you. Oh, good. Then you can help me. Paul's here too. Help me with the syntax of a region. How do I define a region? Pound region? Is that what it is?
Yes.
Okay. What's a region for, since he helped you?
Well, what it helped me with is that way I didn't have that whole list of stuff sitting there. I could close it and it just says.
Just says
class
region.
members there.
What regions are for is they allow you to take code and just put them into a folder, if you will. It's almost like a folder. It just allows me to put divisions inside of a chunk of code. So in here, I'm going to define a region. Here's how you do it. You start with a pound sign and the keyword region. And then after that, a space. And what do you want to call this region? It's like labeling a folder. This is completely ignored by the compiler. It's only for maintenance programmers. What it allows me to do is organize my code. Here's where all the properties are. It's in here. It's in this kind of like a folder, but we can collapse it. That's what Pam was alluding to, is when I do my collapse, it collapses the entire region. And I can see all the regions. So it just allows me to organize my code. This region is going to be for the properties. Shouldn't I create a region for data members? I use them all the time. Maybe, maybe not. It's up to you. These regions, I don't require them at all. It's just another one of those things that helps you organize your code so they can be collapsed and you can easily find stuff when you start getting thousands of lines of code in one file. It's nice if it's organized. When you press enter, you should get, I don't. So I have to type my own end region. They're like curly brackets, right? Except they're named. And now inside here, I can put as much code as I want. And when I collapse, the region collapses. Notice the word region disappears. It just says properties. And when I'm ready, I click the plus sign and I can see what's inside. That's its purpose. That's it. So that I can collapse chunks of code, keep them together, hide them when I don't want to see them, and expand them when I do. Okay, so inside here, we want to create our first property. I usually list my properties in the exact same order as my members, again, for sanity's sake. No rule. Paul was asking me before class, do I have to alphabetize my methods in this JavaScript? Why wouldn't you? Could I alphabetize my data members? Does it make any difference what order I create those in? No. Just like variables. As long as you create them, doesn't matter what order. If you want to alphabetize them, you can. These kind of the way they appear on a form to me. Maybe this is the order that they're in the database, in a field order. Sometimes alphabetizing helps, but then my pepperonis and sausages and mushroom toppings all get separated because they don't alphabetize them together. So it's up to you. I don't have a standard for this, believe it or not. If you wish to alphabetize your properties, you can. I put them in the same order as these. That helps me find them. So in here, we have to say public first. That provides access to the user program. They can get at it. This is my property for my order date. It has to have the exact same type as the member itself. There may be exceptions to that, but I've never used it. And then what do I want to call this property? Same name as the member in title case. So it's the same name as that, no underscore. This is why we put the underscores up here. Couldn't I just leave that lowercase? Oh, yeah, but it gets kind of confusing. Lowercase, uppercase. Underscore, that's a member. It's just a naming guideline, a naming standard. That's not a standard for me, but I recommend it. It's a naming guideline to help you keep members straight from properties. All right, what else do we have in here? That's it, curly brackets. So put a curly bracket on here, and in my case, because of my Volcker settings, the curly bracket stays on this line. In my notes, I have it tucked underneath. Doesn't matter to me. I think some of your standard dialogues came to me with curly brackets underneath. As long as you got them nice and lined up and there's some logic to them and consistency, I'm cool. So we just created a property. Now right now I'm getting a little teal thing underneath there. It's probably telling me, excuse me, you need setters and getters. Here they are. Inside of a property, you create this thing with a name called get. Kind of looks like a method, but it doesn't have a type. This is property specific thing. Every property has to have either a setter or a getter or both. So let's start with the getter. Its name in C# is simply get, and it has its own set of curly brackets. If you have a get, you must return something. What we're saying here is I want to get what's in the order date. Because the other program over here, the main form, wants it. They want to just get it. Its current value. That's all we're doing here. Most getters look exactly like this. All of your getters, let's make it easy, all of your getters are going to look exactly like that. They don't have to. You could do other weird things with them, but most of the time they simply return. Return means send this back to whoever's calling. Somebody's calling. Send this back. What do we want to return? The member, the corresponding member for this object. And now the getter should be happy. I'm still getting my little teal thing here because of the way I declared this property behind this clock property. It should have a setter too. But that's just a warning. So I should be able to now, don't follow because you can't do this. If I go back here now, I have just defined a public access to my order date. And so now when I say, hey, you, Mr. An Order, there's an order date. It's got a little monkey wrench next to it. That's the C# current symbol for a property. And I can get it now. Every time you declare a property, if you make it public, and you should, if you make it public, now the main form, the outside world, has an in. It's like a door. And what this piece of code that we just wrote says is whoever asks, give them whatever is currently in the data member. Well, couldn't we just go up here and put a public on there and give them direct access? They don't have to go through the gatekeeper. Forgetting? Yes. Whenever we do a get, there's not much value in this. But again, that's not the only thing we do. The other thing we often do with properties is give them the ability to be changed. We create what's defined as a setter. This sets the value of a data member, changes it. Now that's risky, right? Because how would the form know what the rules for order dates are? It doesn't.
My get is like just black.
And forgot curly brackets. Who knows? Well, I'll come look. We're at break time here anyway. So let's just do let's do this piece and then we'll be done. This is where there's danger. If I put an order date in here of 7/4/1776, all right, should we accept that? Probably not. What's the rules? I haven't made them up yet. Where do I get the rules? Data dictionary, maybe? Systems analysis requirements documents, who knows? There's rules someplace. But this, the setter, is going to have excess code in it. And it would go right here. Validation goes here. Do the validation first. If everything is legitimate, and we're going to modify that comment in Unit 2. Okay, for right now, notice this is where it goes. We're going to check to make sure that this date is reasonable, whatever that means. If it's reasonable, then we're going to change the order date. And there's the tricky part. To the new value. Huh? Where'd that come from? Looks like a variable, right? Or it looks like it's built in, because it's blue. Where'd that come from? First time I saw this, my jaw dropped. C# is the only language that says whatever they're sending to you, we're going to call it value. Over here, what am I doing if I say this? I'm changing the order date, right? I'm changing it. Just to what? Oh, to a new date. Or we could just say date time dot today. Parentheses, I forget. No. What am I doing here? This says take what's on the right, today, and change the order date. Really what it says is take today and send it to the property. Let the property chew on that, validate it potentially, and if everything is okay, the property changes the data member, changes the underscore order date. But what's bizarre to me, and this is the only language that does it, even the brand new fangled Swift doesn't do that. What's bizarre to me is in C#, they have decided that whatever new value is coming in, its name is value. We're going to do this for every one of those properties. We're going to say take the new value and put it in there and put it in there and put it, but only one of these is ever being executed at any given time. This value is inside here, so we'll never get confused. That's bizarre. No other, right, Paul? I don't think I've seen it anywhere else. Every other language, you give it a name. What do you want to call it? In C#, they go, who cares? Everybody always calls it value, which is probably true. So why don't we just build it in? They did. So whatever new thing is coming, the setter allows me to set. And I'm going to split my screen here. The setter allows me to set my data member, put a new value in there. That's what the setter does. What new value? Whatever the other program sent to me, and it's given the name value. Notice it's blue. That's bizarre. You'll get used to it. The getter gets what's in there and sends it back. And I'm pointing over here, that's the form, okay? I imagine it that way. The getter, the form sends me something new, we call it value, and I put it in there after I validate it. Chew on that for a little while. Take a break. If you can, come back with questions. Otherwise, I'm going to keep going.